Before we do the next step, I just have to show you this, because this kind of next step kind of assumes that you understand the relationships here. So we got two important specifications that's at the heart of this system. One is called application specification. That is basically a way for people that package applications to tell the system what an application has for name, so we can reference it, which images it needs, what configuration, and we'll look at some details here, it requires to run, and something we call vault references, and that will make sense when we start talking about secrets management and strongbox. So that kind of helps the system understand, here's an application with a name. In order to make it come alive in the distributed domain, we have to also tell the system under which circumstances should this application run. And we call that a deployment specification. Deployment specifications has names, not surprisingly. They have application names, or actually references to applications. And then they have what Fredrik almost mentioned, something we call site label matching. So it's label matching expressions that will tell the system, again, under which circumstances, or which circumstances needs to be true for us to actually deploy or start a replica of this application. If or when you feed the system these two, it will go to town and start replicating applications across all matched sites. So a couple of things to glean from this, because this is what we think is going to be very important for anyone building a system that are going to deploy applications across hundreds, thousands, tens of thousands of sites, is that the application specifications, again, are lifecycled by the developers, by people building the software. They are the only ones that know what these applications need. The deployment specifications, on the other hand, should be firmly in the hands of the application operations team, people tasked with running these applications. And if you think like that, you start understanding that in order to do, for example, application upgrades, what you do is you upgrade the application specification, or you edit the application specification to point out, for example, a new version of a container. And a system like this will figure out we're behind on the containers for this particular application related to this deployment, and figure out a way how to upgrade that. And if you want to change the scope of an application, i.e. deploy to more sites or fewer sites or just other sites, you update the deployment specification. And we'll see examples of both of these. And the system will then figure out for you how to actually make that happen. How do we actually expand, contract, or remove the scope of an application? And as a final thing here, just to say, the way to undeploy things or remove things is simply by removing a deployment specification, which will tell the system we have no deployments available for this application, so we'll just remove them all over the system. Now that you have that, we're getting ready to go to the next step, and we're going to do our first trial run with an application. So we have an initial application called the Popcorn Controller application. It manages our awesome next-gen poppers in all the cinema theaters. We have very picky people buying popcorn. It's a very simple, unassuming application. It's a single container. It runs our industrial poppers, and it also, as you will see later, logs the number of popcorns popped in the application log. We will eventually feed that into some machine learning and extract some useful information about that at a later stage. While Fredrik and I was researching this, we of course started looking into industrial popcorn machines. And I will tell you, as a little bit of a diversion here, that there are some awesome monstrosities of popcorn machines predominantly manufactured out of East Asia. This is one of the bigger ones. This is huge. We have smaller ones, but as you can see, they're complicated beasts. So demo time again. Getting ready for Fredrik to take over here. So we're going to add a remote registry to our control tower to teach it where to find applications or container images. We're going to create an application specification and a deployment specification for the Popcorn Controller app. And we're going to observe that being deployed across the entire set of edge sites. And for this one, we're going to stick to the web UI. Take it away, Fredrik.
Thank you, Carl. So back into the UI. So I'm going to go over here to applications and start registering our first application, the Popcorn Controller. So by clicking new application, I'm going to use our forms-based input this time. So I'll create the Popcorn controller. As Carl said, this is a simple application. It has a single service, which we'll touch more upon later, but I'm going to call that the popcorn service. And the next, now I'm actually getting ahead of myself. I'm going to switch gears real quick and go into registries, because I need to tell the system where to get the container images. And we have two options. Either you can push them into the system, or as in our case, we have the containers that we build pushed into the GitLab registry. So I'm gonna say I wanna connect to a new remote registry, GitLab in this case. So I'll give it a name, default, and I point to registry.gitlab.com. And by entering this, so every time we register an application with an image that the system doesn't have, it can actually reach out to remote registries to find those images. So with that in place, I'm going to go back down here, and I'm going to say it also has a container, which is called the kettle popper manager. And here I'm going to paste this in so I don't fat finger it. So this is basically a URL. So if you go to gitlab.com, you will actually find this, this container image sitting there. And now if I hit save new application like this, and I look at the state, the system will actually start looking for this image. And in a short while, it has managed to pull it from GitLab, and I can see that it's present. So now we have described the application, and the system has downloaded the image to the control tower, to the central point, and it's ready for distribution. And to distribute or start the applications in the different sites, I'm going to go into the deployments and create a new deployment. And this one is way simpler. So I'm going to say this is popcorn deployment. Please deploy the popcorn controller. And then I'm going to go here, and here is where I can tell the system what labels to match. Obviously, we're going to run the popcorn controller at every site. So I'll just use the built-in one called system type equals edge. And that will tell the system that this application should be running in all our movie theaters. So I'll hit save here and create. And now if I go into map, you can see that it has chosen to deploy this at 101 sites. I'll switch over to events, and shortly you can see events popping up as it starts deploying them in Pisa in Italy, in Buenos Aires, in Berlin, and so forth. And here comes the really cool part, I think. And that is, as Carl mentioned, each of popcorn controller logs to stand that out, how many popcorns it has popped. So I can switch into logs here, and I can ask the system. So the logs are stored locally at each site. So the standard out is stored locally. But I can ask the system to go to all the sites where this controller is deployed and retrieve logs. So if I hit this one here, I will start seeing logs coming in from all sites. And if I'm interested in a particular site, maybe in Amsterdam, I'll choose Amsterdam and I start retrieving logs. And here I can see the specific application logs for Amsterdam coming up.
So something just again, thinking out of curiosity on here, from an API perspective, being able to do a network audit at each one of these stores using a switch or router, whatever it is, and taking it and identifying automatically which sites have popcorn machines and which sites don't have popcorn machines, automatically creating a tag and then deploying the correct application based on the equipment that's there instead of having to choose which sites. I mean, what the future of this stuff, like looking forward a little bit, like I think that, I mean, it seems like there's something there where it would make it even easier, if you will, because I look at the picking and choosing of this where it's like, man, if I didn't, I don't know that all the theaters in Athens have popcorn makers. And so now I have to call every theater and find out, but wouldn't there be a way to integrate some of that?
So here's the thing, this is painful because so many things happen below the surface here. First of all, we're only showing application logs from the popcorn controller applications. We're not seeing application logs from any other tenants or applications or anything else. And we also on the left side filter on the sites. So what we're seeing is the intersection between a site and an application, right? And the cool thing that happens here is that we actually push the queries down to the sites, right? So we can't listen to all traffic from all application at all times on the northbound interface of the control tower or the web UI, but we actually push these queries into the distributed domain, well, to the edge enforcers, as you guys know them, that we know and understand actually has scheduled the popcorn controller. So we already have a distributed query mechanisms, and what we're seeing here is just one way of looking at it through a web UI. So there are other ways of slicing and dicing it. And I think understanding what you said, that's actually, well, just a query, a kind of a query that we could ask this system through the command line interface. And we think, again, this is just gleaning what is, for example, observability as people would have it these days. What does that even mean if you have an application that runs on 500 out of 1024 and your monitoring tells you that some of them are not feeling so well, right? So this is, again, for us, it's just the beginning of something that we think will be pretty darn new, is how to think about application observability across large, distributed environments.
Yeah, great, thanks.
Last thing before I leave this, kind of in preparation for the next demo, I just want to show you again. So we did everything in Forms, but obviously everything that I typed in through Forms has a YAML equivalent, and that is what we're going to use for the next demo when we go to CI/CD.
Hey, Fredrik, question for you. When you're actually doing the deployment, any thoughts on having like a drop down instead of typing in the actual tags so that you can make it easier? I see Carl laughing in my screen here.
Yeah.
To make it easier and less error prone for selecting tags.
Short answer, absolutely. So drop downs or completions as you type in names and so forth. Yes, absolutely.
And I'm happy you didn't mention the fact that he actually pasted in geolocation instead of actually using the gigantic map that's behind his little window here. So there's a lot of quality of life things that are coming into the web UI as we proceed. So point super well taken. You are absolutely right. All right, so that moved us along in our ambitious generalized requirements list. I wouldn't say we showed you full lifecycle management. We just showed you how to deploy an application across the 100 sites that we just built, but we did some of that. And we're going to move on to the next slide here. We're going to show you something that resembles a more real application. So we're going to start showing you guys something that our companies are, since we're still in the IT department here, our company's development team has developed. And we're going to look at it in their systems. So we're going to start introducing a couple of more powerful things. So I talked about Strongbox before. We're going to show you how to use something called Strongbox for distributed secrets. And we'll use what is actually a distributed key value store. So something you manage from the control tower, but that gets exposed to applications that have the privileges to read it. And we do that to avoid managing sensitive material in application specifications or in environment variables, which is unfortunately best practice in the industry today. Of course, we want to get away from that, and we want a centrally managed way of doing that. So we're going to add a second application. It's called Theater Room Manager. It is way more ambitious. It manages our projectors, our content DRM system, and the curtains in every theater room. It's got multiple services, we'll talk about that term, and multiple containers, and it uses environment variables and volumes. And what we'll do is, again, we'll make this a little more realistic. We're going to move into looking at this through GitLab, because, again, our development team at Movie Theater Corp loves their GitLab. And we're going to actually deploy and eventually upgrade this application using a CI/CD pipeline. And GitLab happens to call that GitLab runners. So we're getting closer to an infrastructure as code, the way people would actually use this. They probably wouldn't point and click for too long, and when they deploy more advanced applications. So the next demo is a brief review of our Strongbox setup. So you just follow what we have. We're going to look at the application and the deployment specifications. We're going to trigger our CD pipeline, and we'll start by deploying the application to all sites in Sweden, because that's our trial market. Check the deployment, upgrade one of the containers in the service across the deployment. And then we're going to also expand the deployment outside of Sweden, because the next version of our application is now ready for European-wide deployment here, and then recheck the deployment through the web UI. So a little flipping between GitLab, where we actually manage the assets, the deployment specification and app specification, and the control tower UI, just to make sure that everything is as good as it should be. With that, Fredrik, I think we're ready to go.
Thank you. So back into here. And the first thing I'll show you before we go into GitLab is, as Carl mentioned, Strongbox. So our DRM, digital rights management system, needs credentials. And each site needs to have access to those credentials. So we choose to store them in Strongbox. So what I have previously created here is a vault we call operations. And in that vault, we have a secret key value map called credentials. And in that key value map, we have stored a username, not very secret, I can show you that, but of course, a very secret password. And these will be made available to the application as we deploy it. So with that said, I'm going to switch over to GitLab, where we store the code for all this, including the specifications. So again, our movie theater group stores everything in GitLab. And here we have the specifications. And if you want to look at it, on top of this, all the code. So let's start with the app spec.
And I've been tasked with seeing if I can manage to make this blob of YAML come alive for you. So first of all, I won't go in through every line. That's too boring. But what you'll see here is that this is an application that has actually two services. One service has to do with the theater operations. One has to do with curtain controllers. And a service for us is something you schedule as a whole on a particular host in a site. And they both have the need to read secrets from our Strongbox environment. And there are kind of two ways to expose the secrets out of Strongbox to applications running in containers in the distributed sites. One is to actually provide a volume. So that would actually become a file inside of the container, which means that no one, unless they are managed to break into the container, can actually see that. So it's not a part of the environment that you can see in the process tree. It's not part of the actual packaging of the application, but something we inject live into the container as it comes up. The second way we do it is by an environment variable, but instead of printing it out specifically, which again, is unfortunately partially best practice still, we read an environment variable called operations username out of a secret map. And then we use that at a later stage. So you will see that there are two ways of interacting as an application with Strongbox. And this also gives us a way, of course, of switching, which of course is coming down the line here, the credentials, if that becomes a problem eventually. There are three containers, I believe, here. So theater operations has a projector operations container, a digital assets manager container, and the curtain controller has a single container. Both are replicated. So if they end up in a clustered site, we will always keep one of these alive. Make a particular note about the version of this application and the version tag of the containers, because that's going to come into play as we sweepingly upgrade applications across edge sites. That's that for the application specification. This one is way easier, not only because you've seen it before, but because it's shorter. So it's the same kind of deployment spec as we showed you before. The match site label core part here is the same as Fredrik had before, system/type edge. Now, as I told you, what we're going to do here is we're going to trial this application in Sweden only. And as Fredrik changes the match site label to match the Swedish region, I will tell you that the way this setup with pipelines work is that when you commit the change, the system will figure out that there's now been a change here. So we're going to shoot off both the application specification and the deployment specification to our control tower using GitLab runners, right? So it actually becomes part of a pipeline. Yeah, you can show that.
Yeah.
And it will be fired off into our control tower.
What happened? Here we go. Here it is. So you can actually see it running. It's usually pretty quick. Well, it's already done. I'll just show you anyhow. So it basically picks up the changes we made, and then it calls into the APIs with those changes. And now if I switch back here, you can see that I have a new deployment, the theater room manager deployment. And this guy is deploying to the Swedish site that hasn't been able to deploy to Stockholm yet. But again, we matched on those country equals Sweden. So it does what you would expect, only deploy it here. And we can look at the events as it comes up. But now the good news is we've deployed it in Sweden. We've tested it out. It works really well. We want to make one change though. We want to upgrade one of the application containers to version 2.0 and at the same time roll it out across Europe. So again, our deployment or our applications team will change here we go. We'll change the application specification right in here. So back to this one, and we'll make a really simple change. First, I'm going to say that this will be version 2.0, of course, and it will pick up a new version of our projector operations container that they have spent a lot of time on, coded it, tested it, and pushed it into the GitLab container registry. And now we're ready to go. So I'm gonna change that, put that back into GitLab, and then on top of that, I'll go back to this guy, and I tell it not only do I want to run it in Sweden, I actually want to run it across the region we call Europe. So now, if I commit this, again, it's going to kickstart the CI pipeline, and that's going to call the APIs, do the updates. So if I go back here, a number of things will happen. You will shortly see in the events here that we will start tearing down the 1.0 version of the projector operations container, and then restart it on version 2.0. And not only that, now you can actually see Barcelona, Helsinki, and so forth. So we have actually started deploying the application across the entire of Europe. So Sweden or Europe, and these are small containers. So they're actually coming up here across Europe.
So prior to it deploying to new sites, does it do any sort of resource checking to make sure that the sites it's about to deploy to can actually run what it's being told to?
Yes, absolutely. So that's actually, if you like, a negotiation between the control tower and the leader edge enforcer if it's a cluster, or the edge enforcer if it's a single host site. It's part of the scheduling mechanism of the edge enforcer to make sure that we fulfill all the requirements. So that can be resources, it can be labels, it can be things like that. I can only run on a host that has a TPM module or something that has this amount of bandwidth. Anything we can glean out of the operational environment, we can match against. So absolutely. So as you can imagine, the filtering expressions on that match site labels can be arbitrarily complicated, arbitrarily complex.
Yes.
Before we stray too far from that last presentation, on the topic of Strongbox, I didn't see any kind of note towards any sort of certifications. So what if you're dealing with companies that require PCI or FIPS or something along those lines?
To be very honest, we're trying to get our arms around what that would even mean in an environment like this. So we're getting there, but it's too early for us. We're trying to map what we've built towards the expectations in both of those. And it does come up, as you can imagine, and that's why you're asking, with customers that are sensitive, that carries really sensitive data, for sure.
In terms of the underlying infrastructure that's running on this, you're talking about obviously free hosts in each theatre and stuff like that. Do you have any awareness as to the health of those hosts, or would you be looking for them to run alternative systems like Open Managed by Dell? Lots of discussion about popcorn butter over machinery and stuff like that over here. I'm just wondering what I've previously worked with distributed systems for global positioning systems in public transport, and had to go and fix servers that are literally caked with dust, stopping the fans from moving. So I'm aware in these distributed environments quite a lot that actually it's sat in a corner, there's no IT person there to manage it. So I'm just wondering if it would need to be a two-part solution where you're managing that application layer and up, and you would still need the ops layer for the hardware underneath.
To be honest, yes, because then, as proven by you and others, that ops layer is actually fairly mature, and us playing catch up at this point with that would be somewhat foolish. And worst case, we'll end up with a toy version that no one actually loves. So currently, in the current generation, we're going to stop at the container runtime. And of course, you will be able to figure out that things went south. But if you're looking for detailed health data, that's not something you're going to get out of the Avassa systems. You're going to be looking at a separate system for that. Is that a good or bad thing? Do you have advice for us?
I think it's a good thing in terms of I'd probably still run that other system anyway. Some level of integration with it to show me some basic level of health or something like that. Because probably on a day-to-day basis, I don't want to be an Open Manage or HPE's equivalent or something like that. And it sounds like it. I mean, I'm an ops guy, right? I love the fact you're showing me a UI here. People here are probably hating that because I know a lot of the true DevOps guys were, let's get on to that bash. But I love the fact that we're talking about containers and we do have something visual. There are people in the ops team that simply aren't able to manage that, and the UI is really important for them, especially the people that are going to be doing the more junior roles of just checking the health and what's going on. So some level of kind of basic status that you might be able to get might be helpful, but I completely agree, you do not need to go into the nth degree because those systems already exist.
Oh, that is music to my ears, what you're saying about the visuals, because we also understand, I mean, as you can imagine, we're a fairly deep tech company, right? So we have a lot of natural gravitation towards what we'll show you in a little bit here, which is a command line tool. However, it is really, really hard to make a distributed environment like this come alive on a line-by-line basis. It is something pretty nice with having a 2D screen to draw on. So thank you for that comment. I'm much appreciated. Okay, so we're going to move along and say that, okay, so we showed you or started to show you how to make maximum reuse of the existing tools and processes. In this case, we started by covering the needs of our development team. And of course, they were delighted that they didn't have to leave their GitLab environment and they could just keep working the way they do with their existing applications. It's just that they now deployed an application across 100 sites, or actually a couple of sites, and then they expanded the scope and upgraded the container without even leaving GitLab, and handed it over to the application operations team.